right, for this video, we're going to show how to do the pressure disc. This part is a little tricky because it uses a tool that we haven't used in a while, and it's a little, the order in which we do our sketches and the way we have to sort of visualize our sketches is a lot different, because we're going to use a tool called Revolve. So we're not going to take a 2D sketch and extrude it in one direction. We're going to take a 2D sketch and pivot it around an axis. If that's confusing, you'll see it when you see it done. It should be a little less confusing. So let's go ahead and do a new IPT part. And we are going to make sure that the right units are selected. Give it a moment to do it's loading here. There we go. All right, so we're going to go under the Tools tab, go to Document Settings, and change our units, which is the second tab in Document Settings. We're going to go to millimeters for our length, and for mass, we're going to do kilograms. And that's it. So click Apply, click Close. All right, so let's go back to 3D Model in the ribbon. We're going to create a sketch on the front, also known as the XY plane. And we're going to look at this. So this is what I mean by using the Revolve tool. So we're going to have an axis, right? In this case, the Y axis like that. And we're going to create a sketch, right? Which you'll see by my blue line here, which goes that way, that way, that way, that way, that way, like this, right? And we're going to sketch out that profile. And then we're going to take that profile and we're going to revolve it around that axis to give us this sort of like frisbee kind of shape. So let's take a look at that in action. Let's go ahead and use the line tool. And we will, from the origin, go to the right and then down, right, down, right again, and down, and that's it. And now we can start to dimension this. So this first sketch, all this is saying is that it's 10 millimeters thick, right? This from the outside of this profile, the inside of the profile, it's 10 millimeters thick. So that is why I did not continue to draw lines like this, because I'm not going to bother, trying to make sure all these are, I'm not going to dimension like all these dimensions. There's a tool that will allow me to offset this by 10 inches, and that's the offset tool, or 10 millimeters, I should say. So I'm going to continue to look down here at these two sketches. These two are where we're going to get our dimensions from. So in order to do the dimensions for how far from the origin these lines are, I'm going to look at the bottom one. And then to find out how far each of the lines are, separated from each other, that'll be the top one. So first, let's do this radius before I forget to do that. So I'm going to go ahead and fill it, this corner, and make that 30, which actually that might not work because this is so small right now. So I'm going to leave that as 2, and then but with the fillet there is good. That's exactly what I wanted. All right, so let's continue. We want to do these distances from the origin out. And because this is going to be a part of a piece that gets swept all the way around, and we've only went in one direction, that our initial circle was awful. Let's see if I can't get that a little bit better. So because we're going to rotate this around, this direction, right, is going to be our radius, because the entire thing would be the diameter, right? Just like that. So since these are showing the diameter, we're just going to have to take these numbers and divide them by 2. So the distance to our first edge here, we're going to ignore the hole at the top because we're going to do that later. So what we're going to do instead is the 170. So we're going to go from here to the origin and make that 170 divided by 2. That's going to make this very large. You can see 170 divided by 2 is 85. Now, after the fillet, the next line is 330. So I'm going to take my dimension tool, go to the next vertical line after the fillet, and go back to the origin. And that will be 330. Again, we are, oops, not 330, sorry. 330 divided by 2. There we go. And then last but not least, the entire diameter of this disc is 400. So from this line to the origin, 400 divided by 2, which of course is 200. But remember, always better to actually let Fusion do the math. You always put in the numbers you see on a drawing. All right, now I can do the numbers that separate these. So this is going to be 15. That left this hanging up here, so I'm going to just drag that back down. Likewise, drag that back down. All right. After the fillet. Oh, well, we don't have a distance for after the fillet, and that makes sense. So instead, we're going to just do this one, which is 10. And then what they did was the entire height. So drag these back up to where they belong. That's 10. Probably better to look at it like that. There we go. I like that better. Okay. So instead they have the entire height. So that's from the very top to the very bottom, 75. So let's do that. From the dot at the bottom to the origin is 75. There we go. Now I can change this 2 to a 30, and it should be much better for a of a dimension. Actually, pull that in there. That looks good. Okay. Now I don't have a closed shape yet, so I can't do anything with this. I can't extrude it. I can't revolve it. So instead, I'm going to need to offset these series of lines in by 10. So let's do that. Let's go find the offset tool in the ribbon here and click this line. And I'm going to move this inward. And now I can put a dimension on that. So a dimension from here to here and make that 10 millimeters of thickness. Now you'll notice that that didn't close the shape entirely. So I'm going to have to put a line that connects there to there. And then this line, this is a dimension. This is in my way big time. Oh, I'll move that over there for now. Okay. Now what I need is I'm going to have to actually delete this line and redraw that. Looks like it left a point there too for some reason. Delete that. Now I can go ahead and put a fresh line in from here to here. And it looks like we're good and fully constrained on the bottom, which is always good. So I'm going to go ahead and finish this sketch. Use the revolve tool. Normally we would use the extrude tool. Let's use the revolve tool and select this shape. And then the axis of revolution can be either that center line, but since that center line was snapped on the origin, the other thing that it could be is if I open the origin folder here, I could also select the y-axis as the axis of rotation. But because that line was on the origin already, I actually don't have to worry about that. So I can go ahead and click OK. And that created most of this disk. A couple things I have to do. we'll create a sketch on the top for this circle, which is 100 millimeters in diameter. That's all we need for that sketch. And it's fully constrained because I put the number in while I was drawing it. So easy. Extrude all, not, yeah, through all. Make sure it's cutting down, which it is. Perfect. Now, the only thing that's missing here is the circles. So we will, on the top view, create a sketch here on this plane. And I'm going, the first thing I'm going to do is create a line. And this line is going to go from the top to the origin, just like that. And I'm going to make it a construction line. Now that I've done that, I can anchor this circle. So I want a circle with a 12 millimeter radius. And from the origin, it's going to be 182 millimeters to its center. So we'll click the dimension tool from the origin to the center of the circle, 182. And now we are also fully constrained there. Now with this, I have a couple of options. I can, when I finish the sketch, I can extrude that hole down through, or I could use the hole tool. So since we haven't done the hole tool yet, let's go ahead and do that. We're going to put this hole on the center of that circle there. It's going to be a simple hole with no counterbore or countersink, meaning no seat. It's going to go through all, and it is going to be 12 millimeters in diameter, which means that the outer edge should go right to that sketch that I made, which is good. So I'm going to go ahead and click OK on that. And now we should have one hole at the very tippy top here. Ooh. There we go. Beautiful. And what we can do now is we will use the pattern tool to multiply this circle again around an axis. In this case, the axis is going to be, well, it'll be the same axis, the y-axis. So let's go ahead and click the pattern tool. The feature will be hole number 1, the only hole that we made there. And the axis rotation will be the y-axis, which I already had open because I had the origin folder open. So if you don't, click the plus sign on the origin folder and you'll find it right there. How many? Well, we could count them, but we don't have to because in the diagram it says that there's 16 of them. So I'll make 16 of them and click OK. Now we have 16 holes around. So if we change the material to copper, material is going to be up here where it says generic. And I'm going to go down to where it says copper. It's in alphabetical order, so I'm looking for C. All right. And then click the part in the browser and go to iProperties, apparently. Yeah, they're using Apple products here. I think that was a typo. So unless there really is iProperties, then I'm going to look like a fool. Oh my goodness, it is iProperties. Well, I guess I look like a fool. I never noticed that I before. Well, I'm keeping this in the video. I have no problem with myself looking like a fool. All right. So physical update. The properties mass is 14.547 kilograms. I hope this helped you to make this shape and learn a little bit more about the way the revolve tool works. It's incredibly useful, especially for something like this, because without it you would have to create a lot of circles and then extrude down, create another circle, extrude down, fillet this rounded edge, create another plane, another circle on another plane, and extrude down. It's so much easier. You do one sketch, revolve it around, done, and then we put in the holes. So I hope this helped you to make this shape, and I will see you in the next video.